We've created a rule that allows us to differentiate polynomials. We're now going to look at, well, what if the power is not a positive integer? Something like this, y equals 1 on x. How would we differentiate that? A function x is 1 on x, function x plus h, 1 on x plus h. Again, we'll go back to first principles. Let's see if we can create a rule. Dubbing it into first principles, a bit of algebraic fraction work to do, but h will eventually cancel, and I end up with 1 on x outside of x plus h. So as x approaches 0, we get minus 1 on x squared. Now if we look at that closely, the rule we had the other day that we created for positive integers, well, if x is negative 1, if I was to use that rule, I get minus x to the minus 2, which is indeed minus 1 on x squared. So it does appear that rule will work not only for positive integers, but it'll work for negative integers as well. Brilliant. That means we don't need a new rule. What about fractional indices then? Y equals the square root of x. Function x is root x. Function x plus h would be root x plus h. That into the first principles formula. Ooh, what do I do here? I'm going to rationalise not the denominator, but the numerator. If I do that, on the top of the fraction now, I'll get x plus h minus x, which is of course h. That'll cancel with the h in the bottom, and now we can substitute 0 in. And we get 1 on 2 root x. Now again, what would have happened if we just used that rule? X to the power of a half would become a half x, subtract 1 from the power, minus a half, and that is 1 on 2 root x. So it works for fractional powers as well. That's great. So that means we've got one rule that will cover any power whatsoever. 3x plus 1 on x squared then. Well, first thing I'm going to have to do is change that 1 on x squared into index form. Now we can differentiate 3 minus 2x to the power of minus 3, which is the answer, but I always think it's good to answer it in the form of the question. The original question didn't use negative indices, so my answer, I'm not going to use negative indices. 3 minus 2 on x cubed. X squared root x. Again, let's put it into index form. That's x to the 2 and a half, so 5 on 2. 5 on 2, x to the power of 3 on 2. That's the mere mortal answer. 5 on 2, x root x, taking it out of the fractional indice form. Becomes very good here now, because how would you expand that out? Well, you could, I suppose, but you can still end up with negative powers. But now I can handle the negative power, so I don't have to bother expanding out. In fact, how would you expand out 5x plus 4 to the negative 2? Anarchy. Bring down the power, becomes minus 4. Lower the power, negative 3. Expel the guts. The derivative is 5. Minus 20, 5x plus 4 to the negative 3. I'll take that out of index form. No, not index form, but negative indices. Minus 20 on 5x plus 4. 3. Now we can differentiate something like this. The square root of x squared minus 3, because that would be to the power of a half. And again, how would you expand that out? Bring down the power, a half. Lower the power, minus a half. Diff the inside, 2x. X squared minus 3 to the negative a half, that becomes x over the square root of x squared minus 3. Alright, that shall do us for today.